Hello student. In this module, I'll be finally talking about the concluding 7th part of the semi-conservative replication of DNA. I will also throw some light on replication in prokaryotes. Once again, look, listen and learn. Okay. In this module, I'll be talking about the 6th part of the replication process called as formation of daughter DNAs. Let us see how are finally the daughter DNAs formed. You remember this picture from last time, right? Correct? Okay. What are these? These are two old strands coming from the parent molecule. Yes, I'm going to call that strand as the old strand. And on this old strand, I just built a 5' 3' new strand. Correct? Now on the right, once again, there's an old strand coming from the parent DNA. And once again, I built a 5' 3' new strand in the opposite direction. Correct? Now what are these two? These are the two daughter DNA molecules. What happens next? Very important, you have to know that simultaneously both the strands will undergo coiling. And let us see how. There you go. See how they have coiled back to their original double helix shape. Yes? Look at the orientations. You have 1 3' 5' old strand, and then you have 1 3' 5' new strand in the opposite direction. Same way on the right hand side, you have 1 3' 5' old strand and 1 5' 3' new strand in the opposite direction. And these will be called as two identical daughter DNA molecules. Is that okay? Let's go back and see something else. What was there before replication? Remember this original picture? You remember? Yes, you do. What happened here? The hydrogen bonds just broke and the two strands separated. That's how the replication happens. Is that okay? And what happens after replication? You build one new strand in one direction and you build another new strand in the opposite direction. Yes, absolutely. Then you're going to put back the hydrogen bonds. Now closely look here. What do you see? You have two old strands, right? And you have two new strands. So in both daughter DNAs, what we see is 50% strand is old and 50% strand is new. Okay, so you can say that 50% of mother molecule is retained or conserved, whereas 50% is newly synthesized or newly constructed. And that's why replication of DNA is called as semi-conservative replication. Because in both daughter DNAs, only half the strand is retained or conserved from the original parent DNA molecule. Is that okay? Yes? Moving on. This idea of semi-conservative replication of DNA was put forward in the year 1958 by two scientists, and their names were Matthew Meselson and Frank Stahl. Okay? How did they prove it? They basically experimentally proved the semi-conservative nature of DNA replication by using a heavy isotope of nitrogen called N15 and the bacteria called E. coli. Okay, so Meselson and Stahl proved the semi-conservative nature of DNA replication. And that is where we end the concept of DNA replication. Now let us throw light on replication in prokaryotes. What happens in prokaryotes? Before that, let's look at prokaryotic DNA. You've seen the prokaryotic DNA before. How is the shape? Obviously, circular. What is the nature of the DNA? Yes, double-stranded. Okay? In prokaryotes, remember, there is only one origin. Okay? Unlike eukaryotes, where there were many origins of replication. And what will happen at the origin? You guessed it right. At the origin, the two strands will separate. Okay? And the replication process will proceed in both the directions. You can see in the picture here. And this type is called as bidirectional replication. Is that okay? Fine. Now look at this structure. In the beginning, this structure actually resembles the Greek letter theta. Is that okay? And that's why in prokaryotes, replication is also called as theta replication. Okay, this brings us to the end of the module where I talked about the seventh and the concluding part of the semi-conservative replication of DNA. I also threw some light on the replication in prokaryotes. In the next module, I'll be talking about packaging of DNA. Thank you and take care.